Hi, this is Deepak, and I'm sharing my screen and showing my presentation for DMML. And as you can see, this is my DML code, and here is the content section. So for this content section, I'm using some Jupyter libraries. So this is for installing that. So in this section, I'm importing all the libraries that is required for my project. After that, I have created models and supporting functions. So this function is for plotting the confusion matrix. Then created some list that will be storing my evaluation data that will be used further for comparison. After that, I've created models function that I will use on three different data sets. And this you can see I have using random forest classifier here, then fitting the data, then predicting the output, and then I'm saving all those all those accuracies and other evaluation matrices to my list, and then computing the confusion matrix and printing like plotting that confusion matrix and ROC curve. The same way I'm doing for logistic regression and decision tree, KNN model, and ADAboost. Earlier, I have mentioned to use SVM in my project proposal, but as I was running for SVM model, my system, I was not able to run the SVM model. It was taking too much time. So I replaced it with the ADAboost model. And after I've created all the models function, then I will start with getting the data, reading the data from CSV file. So I am reading the CSV data for bank, BNM Bank, ABC Banks, and XYZ Banks. So here you can see there are 21 columns and 10,000 rows here, 21 columns and 28,000 rows, and 14 columns and 10,000 rows. After that, I will be checking for the missing data. So I found some of the missing data here. So for missing data in BNM Bank, found some in ABC Bank, and there was none in XYZ Bank. And coming to BNM Bank, first I will do the data cleaning for education and marital status. These are categorical variables, so I cannot remove it, because if I remove, the count of records will be less. So I'm imputing these values with the mode values of all the columns of its respective columns. So here I'm imputing those for all the columns: education level, marital status, income category, and card category. Then changing the data type to string and characters as we require, and dropping the client num, as it is just a column showing the numeric value. And then I'm showing the data attrition values. So here you can see we have existing customer data more and attrition is less. It might show as an imbalance data, but it's a real-time data. So less number of employees, less number of customers have left the bank, more are still with existing banks. And then I'm doing the data transformation. Under data transformation, I'm checking for the normality. So if there is this is the function that I'm using for creating. And after that, I will be checking the skewness. If you can see, the skewness is more than 1. So I am changing it. First one, I'm doing removing the outliers. And then in this section, I'm doing log. You can see log. And then again, checking the skewness. So it is between 1 to -1. Then I'm changing the attrition flag values to 0 to 0 and 1 for calculation. And same for gender, male as 0, female as 1. And after that, I will be doing a correlation matrix for all the numeric values. And here I can see some of the highly correlated values. So I will remove that. So I will remove these three. And it coming to data visualization part, I have visualized different columns data with that recent flag. So I can see like customer age, depending on customer age, how that in fact data is being deferred. Then I've done for gender, and then based on their education level, based on their marital status, then income category, and their credit card. After the visualization, I will do the one-hot encoding. So in this, all the category will become the columns with their values as 0 and 1, and then splitting the data. And then here I'm fitting the model, all 5 models. So this is my confusion matrix for random forest, and then ROC curve. Same for logistics, and all 5 models that I have used. And here I can see the evaluation for BNM Bank data. We have accuracy of 93, 90, 89, 86, 99. And the same way I will be doing for ABC data cleaning, dropping some columns that will not be using. Then I'm checking for the data distribution here. Then doing the transformation imputation as I did on BNM Bank, and changing the gender value, here to 0 and 1, and then checking for the skewness, and then correlation, So highly correlated values are more. So here I have dropped some of the columns, and then I'm doing a data visualization. So here again, we can see for the age based on gender, and then their occupation, their net worth category. Then again, splitting the data, stratified split in. Then I am fitting the model here, and you can see the confusion matrix for random forest, ROC curve. And then for evaluation, if we compare for BNM, we got 93% accuracy. For random forest, for ABC data, we got 84%. So it is the maximum here and here also. And then go for XYZ bank. Same way we are doing the data cleaning and the visualization part. Changing the gender and then checking the skewness. Skewness is all right. It's between 1 and -1. Then we are checking the correlation. No highly correlated data, so no change, no dropping of columns. Then data visualization. So here is the data visualization. And then for based on their gender, and with your geography basis and number of products they have with the banks, and has they have the credit card or not. Then again, you can see here, so I'm doing the fitting of the data with all 5 models I have. And if we check for the evaluation for XYZ, also random forest was highest, 87% accuracy. And so here, sorry. So we can conclude that random forest will be the best model for predicting the churn values for all the 3 data sets. Thank you.